All right, go Boilers. Here we go, class. We're going to do a little bit of fun. Now, the question is how to account for sporadic tasks. Remember, sporadic tasks are aperiodic, but they have a minimal inter-arrival time. And so one thing is to just simply assume they're periodic, schedule them just like a periodic task with a period equal to the minimum inter-arrival time, and then you can just execute, and all the normal RMA, EDF, MUF, MLF, all will work normally. Now, problem is, it is a conservative estimate. In other words, the tasks won't run faster than that frequency, but they could run much slower. So it can result in underutilization. Now, another thing to do is to set aside a periodic time interval and only service sporadic tasks during that interval. Okay? Now again, in that case, the CPU is idle when no sporadic tasks are ready. So it's a lot like just scheduling it as a periodic task. But what we also have is something called the deferred server. This is an approach to set aside a fictitious periodic time interval. That's set aside to service sporadic tasks, but only if they are released. And that's where we're going to get actually a benefit. So the deferred server is kind of similar to round robin with time slicing. Again, we're going to have that same assumption of the relative deadline equal to its period. We set aside this fictitious block. They have sporadic tasks will have the highest priority when the time slice has not been used up, but no priority when the time slice is exhausted. In other words, they don't execute outside of that interval. Opportunity for future enhancement. Now, unused time slices do not accumulate, and you always preempt a lower priority task when a higher priority task is ready. All right, let's check that out and see how it works.